arteries, capillaries, and veins. So in which way does the blood flow? Does it go from like veins to capillaries, then to arteries? Which way?
It's the other way.
The other way, right? So it goes from arteries to capillaries, then to veins. So essentially what's going on here is that, your heart is pumping blood. So blood, that creates like a chain of pulses. So the pulses will travel down arteries and then they will reach capillaries. So capillaries are like, a sponge. They consist of like millions of micro scale blood vessels. And when a blood vessel is that small, they have very large fluid resistance. That means the blood can only travel very slowly through capillaries. So when the blood arrives at capillaries, the pulse will disappear. Pulse disappears in the capillaries, and once the blood exit capillaries, they return to the heart through veins. So only arteries have pulse. So only arteries have pulses. Okay, then when we stick our finger into a pulse oximeter, what's really going on here is that there's a light source like LEDs that shines light into your finger. Light goes into your finger, and light will be partially absorbed by the finger. Then the remaining light will be transmitted and detected by the light detector. So the absorption of your finger contains a lot of physiological information. So here on the top right, I'm showing what is really absorbing light. So first, your tissue and bone absorbs light. Then your venous and capillary blood also absorbs light. Then we have baseline absorption by arterial blood. Then since we have pulses, when there's a pulse coming into your artery, then this added volume of arterial blood. So there's additional absorption due to pulse added volume of arterial blood. So here I'm showing like 4 different components. So the first 3 components, including absorption by tissue and bone, venous and capillary blood, and also baseline arterial blood, don't change over time. So because there are no pulses in these components, so they don't change over time. So we call this the DC component in electrical engineering terms because it doesn't change over time. So this is a DC component. Then there's also an AC component, which is coming from pulse added volume of arterial blood. Okay, so these are the AC and DC components of light absorption. Then, our sensor is really detecting transmitted light. So what that means is that, let's say we have incidental light, then we, minus absorbed light gives you transmitted light. Do we agree on this? Okay, good. So if we look at, the transmitted light signal, we'll see the 2 waveforms are kind of, inversed. That means when we are at the, peak of the pulse, the absorption, is the strongest, then the transmitted light is the weakest. Then when we are at, the foot of the pulse, absorption is the weakest, then transmission is the strongest. So the 2, plots are kind of inversed. Okay, so when we are at the peak of a pulse, then the corresponding transmitted light intensity is called I systole. And when we are at the foot of a pulse, the corresponding transmitted light intensity is called I diastole. So, but what do they mean here? What's the English meaning of these 2 words, systole and diastole? Because I'm not a native speaker, I didn't know them initially. So can someone tell me?
Systole is when the heart's contracted, and diastole when it's not contracted.
Correct. So, when the heart is contracting and pumping blood, that's called the systole phase. And when the heart is not contracting and at rest, that is called a diastole phase. Okay, so these two parameters are very important when we do SpO2 calculation. Just want to bring them out first. Okay, so what information can we get when we look at these two plots? So they are essentially the same plot. So for convenience, just let me just look at absorbance. So when we look at this waveform, what information can you get? What kind of information can you extract when you look at this waveform?
Frequency.
Frequency. The frequency of what?
Heartbeat.
Oh yeah, great. Okay, so first we can look at the frequency or like the interval of the pulses